Alright, what's up guys? Probability by Pitman, Chapter 2, Review section, problem number 24. So, in a large population, the distribution of the number of children per family is as follows, and you guys can read it right there. Assume that each child in a family is a boy or girl, probability half, independently. If a family is picked at random, what is the chance that it contains exactly 2 girls? Okay, so, basically we're trying to find probability that we have 2 girls and n children. So, probability of getting 2 girls, and we have to realize that n children and 2 girls are independent of each other, or not independent of each other, right? Because if you have 0 children, you cannot have 2 girls. If you have 1 child, you cannot have 2 girls. But if you have 2 children, then you can have 2 girls. So basically, they're dependent on each other. So we should write it as P of n children times P of 2 girls given n children. So since they're dependent on each other, this is how we'd calculate the n probability, since the n children would not cancel out, because this probability doesn't directly correlate with this one. So the probability of n children is literally whatever we have here. So P of n child, we'll just leave it like that. But then we have to realize that probably 2 girls given n children is basically a binomial distribution, right? Because we define the number of successes as, or the success is having a girl, right? So having 0 girl, 1 girl, 2 girl, 3 girl, 4 girl, 5 girl, probably having a girl or boy is half. So we can write this as some sort of binomial probability. So n choose k, or sorry, n choose 2 for 2 girls and n total children times half to the second power times half to the n minus 2 power. And you'll notice that these simplify to half to the nth power, but we'll write it out like this just to keep it simple. Alright, cool. So from here, it's literally summation, right? Since we have it for each term, the probability of having n children and 2 girls. So now they're asking if a family is picked at random, what's the chance that it contains exactly 2 girls? So we should go through all different types of families. So any of these randomly picked families, types of families, and then just go about doing it. So we'll do P. So I'll just write it brief. So this is this one. So P2, 1, where there's 2 girls and 1 children, plus P2, so 2 girls, 1 child, or sorry, 2 girls, 2 children. Oh, sorry, I forgot the 0, didn't I? Here, okay, I'll write this as 1. So 2 girls, 0 children, 2 girls, 1 child, plus dot dot dot, all the way up to P, 2 girls, 5 children. Okay, so I'm not going to write these out since we know that the binomial distribution will always be, since we know that these will be 0, because you cannot have 2 girls when you have 1 child, right? If you do 1 choose 2, you'll end up with 0, which means the binomial probability is equal to 0, and hence the whole term is equal to 0. And obviously, the same thing will happen if you do it with this one. 0 choose 2. Okay, cool. So we'll just do from 2 onward, so 0.3 2 choose 2 half to the 4th plus 0.2 3 choose 2 half to the 5th plus 0.1 4 choose 2 half to the 6th plus 0.05 5 choose 2, sorry, it's a weird 5, times half to the 7th. And that is our answer for part A. Alright, so sorry for that pause. So for part B, if a child is picked at random from the children of this population, what is the chance that a child comes from a family with exactly 2 girls? So this one is a little more interesting. So you have to remember that the value of mu, or the expected value for a binomial distribution, is equal to NP. So using this formula, we can just take number of families with 2 girls over number or total number families. All right, I think that formula is fairly self-explanatory, and we can calculate it pretty easily. So basically, we take, this is our P and the NP, and then we just multiply by the total number of children. So it'd be 2 times 0.3, 2 choose 2, half choose 4. Remember, this is like a subset of 0.3, of that 0.3, plus 3 times 0.2, 3 choose 2, half to the 5th, and then do this all the way up to the last term, which would be 5.05, 5 choose 2, half to the 7th. And then we have to divide by the total number of families. So this one will be slightly easier. So we can do the exact same formula, just with this is our n and this is our p, because we're not taking a subset of these families where there are 2 girls. Instead, we're doing all the people with n children. So it'd be 0 times 0.15, which I won't write out, but it'll, and then plus 1 times 0.2, plus 2 times 0.6, all the way up to 5 times 0.05. So, sorry, 0.2 plus dot dot dot, all of the ones in between, all the way up to 5 times 0.05, and there's our answer. Alright, cool. I hope that helped, and thank you for watching.